Bismillahirrahmanirrahim and Assalamu alaikum. October 1989 Phillips 66 disaster at USA. At approximately about 1 p.m. on 23rd October 1989, Phillips 66 chemical complex near Houston, USA experienced a chemical release on a polyethylene plant. A flammable vapor cloud was formed, which subsequently ignited, resulting in a massive vapor cloud explosion. The initial blast registered about 3.5 on the Richter scale. The consequences of this explosion resulted in 23 fatalities and about 130 to 300 people were injured. Extensive damage to the plant facilities occurred. Description of the site. Phillips 66 chemical complex is located near Houston Ship Channel. Within the 800 acres of Phillips property, the area directly involved in an explosion was approximately 500 feet by 750 feet. The blast wave did major structural damage to the other structures, which were quarter miles away. Windows of the Jackson Intermediate Schools were blown off. At local headquarters of Oil, Chemical and Atomic Workers International, ceiling tiles fell and the desk bounced because of the shock produced. Chemical reaction in the plant which faced the accident. There were same chemical reaction occurring in the plant 4 and plant 5 of the Phillips 66 chemical complex, and each plant consists of 6 loop reactors. The chemical reaction that was occurring was the polymerization of ethylene molecule at an extreme conditions of 600 psi pressure and 180 degree Fahrenheit to 230 degree Fahrenheit temperature, using isobutene as a solvent to produce high density polyethylene HDPE, which is used in the manufacture of various plastic products. Normal operation of the plant. To understand fully that what had happened in the plant of Phillips 66 chemical complex, or what went wrong which causes the accident at this plant, we should first understand the normal operation of the plant. In the normal operation, the process is circulated through an arrangement of 30-inch diameter pipe mounted vertically on a 150-foot tall continuous ring-like structure called the loop reactor. Ethylene gas dissolved in isobutene is reacted in long pipes under elevated temperature and pressure conditions. Hydrogen and hexane were added to achieve the targeted product quality and specifications. Thus, the raw materials in the loop reactors are flammable and easily ignitable, especially at the reactor's severe operating condition of 600 psi pressure and 180 degree Fahrenheit temperature. The catalyst is used to accelerate the rate of ethylene monomer polymerization and to facilitate its conversion into heavier, high-density polyethylene molecule. The high-density polyethylene forms particles which settle out in the legs of the reactor pipe and are drawn out of the leg through the valves. 6 settling legs were located at the bottom of each loop reactor. At the top of each leg is an air-operated ball valve, which is kept open during the normal operation. Clogging of the high-density polyethylene particles occur periodically in the settling legs, and on these occasions the top ball valve is closed and the legs is removed to clear the blockage. The process is continued during the operation as the product is able to settle out in the adjacent settling legs. This routine maintenance to remove the clog is a critical activity because effective energy isolation and control was required before and during the maintenance of these settling legs. failure in effectively isolating the process will result in huge loss of flammable that critical maintenance which became the cause of the accident. 3 of the 6 settling legs of the reactor 6 of plant 4 were plugged on October 22, 1989. Workers isolated the settling legs by means of a double block system, which involves closing of the 8-inch ball valve, locking them close, and disconnecting the actuator air hoses. Polyethylene logs from each of the plugged settling legs were removed. Those 3 plugged settling legs were disassembled and unplugged without any difficulty on October 22, while the reactor was operating normally. During the clearing of the other 3 settling legs, part of the plug remained locked in the pipework. A member of the team went to the control room to seek the assistant. Shortly afterward, the release occurred. Approximately 2 minutes later, the vapor cloud ignited by an unidentified source. Sequence of explosion occurred in the nearby storage tanks after the initial blast. Emergency response at the Phillips 66 chemical plant after the blast. Phillips Fire Brigade provided the initial response with firefighting equipments and the first aid. There was no dedicated water system for fighting the fire. Fire hydrants were sheared off by the explosion and the water system became ineffective. Water supplies then were established from the remote places, including the neighboring plant. It took about 10 hours to extinguish that fire. Reasons for the accident. Investigation was carried out by the OSHA, which revealed the following reasons. Improper isolation. Ball valve actuator mechanism did not have its lockout device in place. Recommissioning. Investigation found that single isolating ball valve was actually open at the time of release. This would have happened because the connector for the opened and closed side of the air hoses were identical. These air hoses to the valve had been cross-connected so that the air supply that should have closed the valve actually opened it. Positioning of the detectors. The site held a large inventory of flammable material under high pressure, yet it had no fixed gas detector system which could alarm after the initial release of the gases. Permit to work system. An effective permit to work system was not enforced in the company. Plant layout or the positioning of the administrative blocks. Buildings that were occupied with the peoples were not separated from the process unit in accordance with the acceptance of engineering principles. Emergency response. The fire protection system was not maintained in a state. Lesson learned from the Phillips 66 chemical disaster involve continual employee training. Continual employees training in regard of the emergency response procedure is necessary. Adherence to the safe work practices. It means that normalization of the deviance must be avoided. The lesson learned here is to recognize that the process design, operating procedure and the maintenance procedures are all linked to an overall process safety and risk management program. When a system does not meet its design spec, an alternative operating method should not be sought to cope with the issue. That is, avoid jugars. This plant was designed for the continuous flow of HDPE without clogging in the settling leg. But when the clogging occurred, they normalized this deviation by performing maintenance regularly to remove the clogging instead of investigating the cause of clogging. Location of the control valve. Automated sprinkler protection system should have their main control valves and connection below the ground level if possible. So in case of explosion, they might not be exploded or sheared off. For further understanding of the Phillips 66 disaster, you can read about this topic from the given references.